This is your Calculus 3.4 video on the derivative as a rate of change. So your objectives are to be able to solve problems involving motion along a coordinate line, free fall applications, understanding motion from graphs, which is like physics, regarding distance, velocity, and acceleration, and about economics. So why we're studying this is in this section we study applications. It's going to be word problems and interpreting problems in which derivatives model the rates at which things change. It's natural to think of a quantity changing with respect to time, like as time goes by, something happens, like the velocity increases, the acceleration decreases, whatever the case may be. But other variables could be treated the same way. For example, an economist may want to look at how the cost of producing steel varies with the number of tons produced. Or an engineer may want to know how the power output of a generator varies with its temperature. You also might be interested with how much oil is in the reserve, which has to do with making gasoline. So there are different ways to think about things, different variables besides just what we're using. If we interpret the difference quotient, again it is a quotient because you're subtracting and dividing, and that's f of x plus h minus f of x over h as the average rate of change in f from x to x plus h, we can interpret the limit when h is close to 0 as the instantaneous rate that f is changing at that particular point x. This gives us an important interpretation of the derivative. The instantaneous rate of change is the derivative. The limit as h approaches 0 of the difference in f of x0 plus h and f of x0 provided that the limit exists. Thus, instantaneous rates are average rates. So now we're going to talk about motion along a line, specifically displacement, which has direction, like a distance east, for example, or whatever, velocity, speed, acceleration, and even jerk. Now, if you take the derivative of each one, you get the next. And so it's like, well, velocity and speed are pretty related, but because speed is just positive. But the derivative of displacement is velocity, the derivative of velocity is acceleration, and the derivative of acceleration is jerk. Not just somebody who cuts you off when you're driving. Suppose that an object or a body considered as a whole mass is moving along a coordinate line, which could be an s-axis for distance. It's usually horizontal or vertical, and we know the position as a function of time, so s equal ft. The displacement would be f of t plus delta t minus f of t. There's going to be a lot of formulas you have to do on these. Okay, so for the displacement, you have to do the change in s, which is basically the change in f. Now for the average velocity, then you do displacement divided by time, because you're going to think meters per second or miles per hour just as a couple of examples. You could have smaller examples like feet or centimeters, but those are basic ones to remember. To find the velocity at a particular instant, we take the limit of the average velocity as the delta t is getting small. This limit is the derivative of f with respect to t. Now the velocity, in particular the instantaneous velocity, is the derivative of the position. So it's like if s is a position, then s prime is the velocity. If the position is s, which is f of t, then the velocity is v of t, which is ds dt, or you could say s prime, which is that limit. So besides telling us how fast an object is moving along a horizontal line, the velocity also tells the direction. If it's moving forward, then s is increasing. So if you have an increasing graph like that or like that, that's going forward because it's increasing. And so the velocity would be positive in that case. Now if it's going backwards like that or that, it's going to be decreasing. Now, that is for a horizontal line. I'm kind of like breaking it up. Now, if the line is vertical, then up is positive and down is negative. So in our example, if we drive to a friend's house and back at 30 miles per hour, the speedometer is going to show 30 miles an hour on the way over, but not negative 30 on the way back, even though our distance from our home is decreasing. So the speedometer shows speed, which is the absolute value of velocity. So it's like s equal the absolute value of v. Speed measures the rate regardless of direction. So it's not like you can be like in the Ferris Bueller movie where they put the brick on the gas pedal with it stationary and they're trying to run miles off the odometer. You can't do that. So your speed is the absolute value of the velocity, which is your ds dt. The rate at which the velocity changes is the acceleration. So v prime is a. The acceleration is how quickly you pick up speed or lose speed. So like when you're revving up your car or like the first few seconds before you get it up to 55 miles an hour or 30 miles an hour. Now, if you do have a sudden change in acceleration, it's called a jerk. That's when your head like goes back and forth a little bit. When a ride in a car or bus is jerky, it's not that the accelerations are large, but the changes are abrupt. So like somebody brake checking. Acceleration is the derivative of velocity with respect to time. If a body's position at time t is f of t, then the acceleration is the derivative of the velocity, which is like v prime, and it's also the second derivative of the distance. Now jerk is the derivative of the acceleration. So they use like all these symbols, the derivative of acceleration, or you could say the third derivative of the distance. Near the surface of the earth, all bodies fall with the same constant acceleration. Remember that's like negative 9.8 meters per second squared. or I think we say negative 32 feet per second squared, I think. We have this formula, s equal a half g t squared, where g is your acceleration. Now you also have derivatives in economics. So those that are interested in business, you do have a math related to calculus. Economists have a specialized vocabulary for your rates of change and derivatives. They call them marginals. In a manufacturing operation, the cost of production, C of x, is a function of x, the number produced. The marginal cost is the rate of change of cost with respect to production. So that's dc dx, or you could say c prime. When a small change in x produces a large change in the value, then it's sensitive. The derivative f prime is a measure of the sensitivity. It's more sensitive when f prime's absolute value is larger, which means when the slope is steeper. And you had an Austrian monk, Gregor Johann Mendel, working with garden peas and other plants, provided the first scientific explanation of hybridization. Okay, so now let's actually jump to the problems. Now, there's only 8 problems on this assignment, but they're very lengthy. So like when I did this on paper, about 5 years ago, 6 years ago, whatever it is, we did 1 to 17 odd, and this was problem 1. You have 3 parts, and you have to do your displacement, and then your average velocity. So those 2 are part of A. You had to do your speed and get some numbers. Then you had to do your acceleration, get some numbers. Then you had to get where it was changing direction and test points. And if both were negative or both were positive, then you did not have a sign change. So it did not change direction. But if you get 1 negative and 1 positive, then you would. So that's the type problem we're going to be doing for problem 1. So let me pause this just for a moment. Okay, so on this first one, we have a body moving on a coordinate line such that it has that formula and it tells you that interval. And we want to find the displacement and the average velocity first. So for the displacement, we have to use the endpoints. So that'd be S, well, I could say F, but I'm going to say S. S of 5 minus S of 0. Now, one way to do this is just plug your numbers in. Obviously, the other way is to do this on the calculator. That way you can get both at the same time. So there's the graph, and we want between 5 and 0. So at 0 it's 6, and at 5 it's -4. So at 0 it was 6, and at 5 it was -4. And so then we do -4 minus 6, which is -10. And that's how you get your answer. The next part is the average velocity. So that means displacement divide by time. And so you already have the part as negative 10, and then you do 5 minus 0. So that's just negative 10 over 5, which is negative 2. So that's that one. Now you have speeds at certain left and right endpoints of the interval. And so this is where, starting with speed, you're going to use the derivative. So for this, you have your speed equal your absolute value of the derivative of s with respect to t, or you could say absolute value of s prime. So what we first need to do is, from this formula, we have our t squared minus 7t plus 6, and we need to take our derivative. And so s prime would, okay, so that was s. S prime would be 2t minus 7. So that's our derivative formula, and then we have to plug in our endpoints. So s prime of 0 would be 0 minus 7, which is negative 7, and we take our absolute value to get 7, which is this one. And that is the left endpoint. Remember in English when it says respectively, that means like left was listed first, and so this is the left. Right was listed second, so this one's the right. Okay, so we have the left. Remember again to take your absolute value. And then for the other one, we do s prime of 5. And so then that's 2 times 5, or 10, minus 7 is 3. And again, the absolute value of 3 is 3, and so that worked out. Okay, so we've done the speeds at the left and the right endpoints. Now we need to do the acceleration. And so for the acceleration, you do the second derivative, and so that's just going to be 2. And so you would have the same number for both the left and right. It's the same for the left and the right. Now the next part is about the changing direction part. So how you figure out about changing direction is you set v of t, or you could say s prime, equal to 0. So we have 2t minus 7 equal to 0, which means 2t is 7 and t is 7 halves. So that would be the possible number that goes there, but don't just assume that since you have a number that goes in the blank. In other words, you still need to check if a sign change. Because if both are negative or both positive, then does not change direction. So what we have to do is go from 0 to 7 halves, and then we have to go from 7/2 to 5 because our original interval was that. And so what we're doing is checking a number between here and here. Like on this one, 7/2 is like 3.5, so I'm just going to say check 2. And on this one, I'm going to say check 4. Okay, so if we're checking 2, then we're going to go 2 times 2 minus 7. So we get 4 minus 7, which is -3. The whole point is that it's negative. On this one, we're checking 4, so we do 2 times 4 minus 7. 8 minus 7 is 1, which is positive. Now that you do see that there's a difference here, then it did change direction. And so that's why you would enter 7/2. Okay. All right. That's a good stopping point to get you started. That's about 20 minutes, and we'll do more later. Hope that helps.